Ready? Steady? Good. Okay, deal.
Okay.
So, shall we start? So please welcome this Ivan and Steven from Belyy. Yes, so. And they're gonna have kind of a technical talk, something like question answer session, right?
With whom? With us?
With us, you can then join our conversation and ask your own questions. We will be talking in English. My friend Steven and Jeram came from London, and
my Russian isn't too good.
yeah, and his Russian is
Like your English.
Yeah, very limited. To спасибо, пожалуйста, пиво.
You don't want to use the
Exactly.
Right. Okay, guys. Hello and welcome. My name is Ivan Belyy.
I'm Stephen Jeram.
Steven Jeram. We work for IdeaWorks company. We are engineers on Monolith SDK project. Actually, this project is supposed to provide the ultimate portability and cross-platform capabilities to you.
Well, it's for cross-platform mobile development.
Cross-platform mobile development, and that's what we do, and that's what we want to discuss with you. Is it possible to have cross-platform and performance combined? Is it possible to have the highest performance on mobiles and the cross-platform? Please, Steven, tell us what possibilities can be used for creating mobile platform, cross-platform mobile applications.
Well, traditionally for most portable applications, people commonly use languages like Java and Mono and C#. HTML5 is rapidly becoming more popular, so that's JavaScript. Lots of scripting languages such as Python are sort of your most portable options.
Yeah, and please, if we talk about virtual machine-based languages, can you describe us their pros and cons, their for and against?
Sure, so people choose those languages because they afford you rapid development. They've got good tools, good debuggers, nice IDEs, quick turnaround on running your application on mobile devices.
What about memory management? What can you tell about?
That's one of the nice features that helps with rapid development, is that generally you don't have to worry too much about your memory management, though on mobile platforms where you've got limited resources, you might start to encounter problems where you do have to start worrying about resource management.
So from good side, from pros, we move to cons. And what are cons for virtual machine-based cross-platform development?
Well, you might start to feel a bit limited by your choice in implementation language. If suddenly you decide you want a feature that your OS has that you might not have easy access to. If you're writing a HTML5 application and you want to read the accelerometer, for example, you're going to start to encounter problems. So you're limited by your platform.
And in fact, you wait for virtual machine developers to implement that feature for you.
Yes, if they do. Or there's possibly some tricky routes to access things, but it's going to be difficult.
Okay, and is it fast? I mean, virtual machine, are they fast enough for
it depends on your application. So lots of applications, those languages are fine, but sometimes if you're writing, depending on your, if you want a resource demanding application, you might start to feel the limitations of performance.
Okay. What can I add? If we want to use tools, we got used to libraries, we got used to like Boost.
Oh yeah, if you're familiar with the C++ world, your favourite libraries like Boost are not going to be available to you in JavaScript. And you might not want to learn the language.
True. And if we talk about C++, what can provide C++ for us?
Well, it's probably your favourite language. Yes. It gives you the potential, at least, for getting the best possible performance. Lower resource overheads. You're not going to worry about your virtual machine eating some memory or doing something behind your back, like consuming lots of memory. If there's some bugs in your virtual machine or their libraries, they might be very difficult to avoid. And yes, you've got a more direct access to your platform, so anything that your platform provides, you're going to have easier access to from C++.
And this is good. And what about cons?
Well, I can't think of them.
Yeah, sorry guys, we don't have enough room for cons.
Sorry, we don't have any cons.
Yeah, no cons.
Well,
in fact, Steven can say few cons.
well, the biggest one is that your application is at risk of becoming less portable. C++ wasn't designed from its origination necessarily to be as portable as things like Java.
Yeah, and what can I add is increasing complexity. It's not a big secret that manual memory management increases the complexity of the application, and let's say HTML5 and JavaScript with all those tools for layout control for your application, or Java with all the tools will get a better deal in simplicity of your application. Yeah, complexity is what we have, but we do not afraid of it. We are C++ developers. Yeah, so what can you list as resource demanding applications?
Well, commonly, anything that involves large amounts of data processing is a good candidate for C++. So, image and video editing, if you wanted to apply some graphical effects to a photo, you want to write a DJ application for mixing different soundtracks, anything where you want to get down into the nitty-gritty of processing data, you might want to start writing some C++ code. The last examples we got there, document rendering, like if you wanted to write your own Flash player, or write your own web browser, write your own scripting engine like Lua, and games sort of commonly bring all of those elements together and are looking for the best performance to give the best graphics and the best sound.
Stereo pictures, 3D sound environment, and so on and so on. Well, agree. And in fact, we were talking that one of our C++ cons was that we can make our application less portable. And let's talk about code portability. What makes our code more or less portable?
Well, each time that you call a platform-specific API, you're making your code less portable. If you start using, like on iOS or Mac, you start using NS String instead of like the standard string library, then immediately your code's less portable. If you start adopting, like lots of platforms have different methodologies for how you maybe organize your data and your views, separate them. If you start to follow that methodology without thought, you're going to start locking yourself into that platform.
Okay, and what can us help to make our application more portable? What can we do about the design of the application to help with the cross-platform?
Well, it's basically, again, the concept of encapsulation. You want to move your use of platform APIs into a limited number of source files, talk to them through a smaller set of APIs that you define to separate out the parts of your program which are platform independent, the business logic, and the platform dependent code, like maybe how you load files or how you create your GUI.
So, am I right? Please correct me if I'm wrong. We want to make our application as a layer cake, as a Napoleon. So we want to split it into separate layers. Make split platform dependent code from platform independent to be able to work with them separately.
Yeah, this is to make a portable application. It's sort of ideal to separate your code something like this, where you've got the platform independent stuff at the top. It talks to some API that probably you decide what it is, and then you implement that common API for system functionality on your whatever different platforms you're targeting, and only at the bottom level you talk to your operating system. So in this way, hopefully you don't have to change any application code, include any hash if-def windows at the top level. You're only doing that towards the bottom.
And please tell us a few words about communication between these levels. What way do they communicate? And or at least what way do they supposed to be communicating?
Well, we hope that your application code, as we said, doesn't have any knowledge really of what operating system it's running on. It just talks through this common set of APIs. And also your platform code has no real specific knowledge of your application, what it does. It just provides services in a generic manner. If the platform needs to report something back to your application, it sends a generic event saying, I don't know, here's the latest value from your accelerometer, gives that to the application, but it doesn't need to know, I don't know, load level 1 or anything. It's just providing services.
So nothing about main character, nothing about 80th level, or nothing about our equipment on our character, right?
Right.
Okay, and can we work with all those levels separately? If compile them separately, build them separately. Is it possible?
Well, you start to. This is a simple example, right? We want to use libpng, a standard sort of cross-platform library, and in our application we want to do something like load the image, give it a path. libpng does the job of decompressing our image, and at the bottom it wants to talk to the platform and open a file, read some data. And we've immediately got a problem because at the top we're passing a path, and that path is going to be dependent on the platform possibly. You know, it might different platforms locate files in different locations. You know, my images on Windows.
So you want to, you are saying that it may vary, and you want to somehow be able to control the location, the exact location where the file is.
Yes, I mean, ideally, we'd want to always give the same path for opening an image and not worry about this platform detail of where the image is located.
Okay, and in fact, what we want to do is to replace fopen with our custom fopen, right?
Yeah.
And how can we do that?
Well, one way of doing this is using fopen is from our C standard library. So if we want to replace fopen, we want to replace our C standard library in effect and start taking control of how that works on our system. And a route to doing this is using newlib, which is actually the C standard library, which is these days included with the GCC compiler. And we can actually use that though independently as in a sort of bare bones fashion, which isn't linked to a particular platform. It allows, it's called like a bare bones version of the newlib library, which we then provide the system specific sort of calls at the bottom. We just have to provide these system calls for our platform, and in these system calls we account for the differences between platforms. So in that list we've got open. Open, our application is provided a single image path, and in that image path, in open, we translate it for platform.
So in fact, you want to say that if we replace all these 17 system calls, if we replace these 17 system calls, we actually can replace the operation system for end application, for user application, and we can replace, substitute standard libraries, and we can do whatever we want, such as profiling, such as
maybe tracing.
Or
it also provides you opportunities to, you can log each time a file's open.
other ways of memory management. Say we can replace malloc.
Yes, if you've replaced your C standard library, you've taken control basically also of things like memory management. You could provide your own memory allocator that malloc uses instead of whatever your system uses.
Okay, and so as far as I understand, this is kind of glue between newlib and iOS, and I think we can experience a problem, linker error. Yeah.
So this is a nice idea, but we've potentially got a problem. Our program now has two versions of fopen that it wants to use. Our app code wants to talk to our customized fopen, but then at the bottom we still need to open the file, so we need to call the platform's version of fopen. And if we just try and throw all of this stuff at the linker, it's going to give us an error saying there's multiply defined symbols. You've got two versions of fopen that you're trying to put into your program.
Yeah, and so what is the way of solving that problem? How can we avoid multiple defined symbols?
Well, we need to separate out our linking of our application into two distinct steps. we have what is called pre-linking at the top there, where we take our application code, our libpng library, and our customized newlib library. So the layer sort of towards the top of our cake, and we can run the linker with a special option that says, I want another object file, but I want you to resolve as many symbols as you can and link, basically do the job of linking as much stuff as possible. It'll pull in, so our application code is linked to fopen in our newlib, and give us out a library which is standalone, apart from needing implementations of those 17 system calls. And there's some details about that pre-linking step, because when we're talking about multiply defined symbols, once we've done our pre-link step, and we've pulled in the version of fopen that we want at this stage, we want to hide that within our object file, and there's some other options that we give to the linker to do that. And so now we've got another object which represents our application, and we pass that again to the linker, but now is more of a regular link. You've basically got a regular library for your application, and you link against the normal version of the C standard library.
So you are splitting application library, user application library, and common APIs, or let's say loads that application library. You resolve all the dependencies, remove them, and you now have binary that is able to be used on any platform without any specification. So we compile binary, let's say, for ARM processors, and we can use it for ARM, right?
Yes.
On all the platforms, no matter iOS, is it Android, whatever.
Yes, we've done what we were wanting to achieve, which was entirely separate out our application into platform independent part at the top. This has no knowledge of the OS, and platform specific parts. And so now we've got a completely platform independent part. That is a part that we can reuse across different operating systems.
Very good. Very good. Yeah. So we have separate library.
Now, so we've got a platform independent part and a platform dependent part separated out, but we're still linking them together statically into our final executable. We can actually possibly go one step further, and instead of doing that statically, we can do it dynamically on the platform at runtime. And so this is a nice idea again, but
yeah, it looks like really nice idea. What can you say about bugs in application and in loaders? Is it possible to split them also? And are we sure that if we experience bug in our application, we can work out it, somehow solve it without using platform, without using mobile?
I think, yes, if we can get to this stage where we're loading some, we're saying our application library, which is completely platform independent, if we can get to this setup where we're loading it dynamically at runtime, we've achieved some interesting things, such as any bugs to do with the platform. We sort of isolated them within the top there, what we're calling a loader, and any sort of application business logic example, business logic bugs, we isolated into our application library, and we know that our bugs are sort of independent of the platform we're running on, and we've also gained control of our system.
Okay. And in fact, we have virtualized environment without overhead. So we have the same as Java, let's say, has, but we don't have a virtual machine running, and this gives us a performance boost. Am I right?
Yes.
Really good. And so the problem is, now we move to the next problem, to dynamic code loading. How can we do that? So how can we achieve that loading on runtime?
So we want to create, this application platform independent library, and different platforms generally load code dynamically in different ways. Like on Windows you have dynamic link libraries, on macOS you have the Macho format. But if we're going to really reuse our application library on all these different systems, we need a common way of being able to load code on all different platforms. And one way that we've used to do this is using the ELF format, which is a standard format which is used on many systems for loading application binaries.
Such as Linux or
PlayStation 2, Wii,
Symbian.
they all use the ELF binary format for their applications and their shared objects or shared libraries.
And do we use ELF as itself, or we do any changes to it?
Well, there's options there. We can use ELF. We can ask our linker to produce an ELF file. We just then have to do the job of loading this ELF binary ourselves, and that involves some technical trickery, which suddenly things that the operating system usually provides for us, like resolving symbols dynamically at runtime. That's something that we start to have to get involved in. We have to worry about relocating our executable to a different memory location, and fixing up symbols.
Yeah, and can you tell us a couple of words about this ELF format, what it is, how does it work, maybe anything,
Well,
what it contains, some technical detail.
Well, the ELF format, when you look inside it, it's like many executable formats. It has different sections. It's like text, which is used for like static data, and you have code sections, and it's got various tables for like the procedure linkage table, which is where at runtime your function calls which talk to the system, they have to be hooked up via the procedure linkage table. The global offset table is used to find your static data at runtime.
Okay, thank you. So, in fact, what we have the loader that loads our application library. In fact, our application, user application, that has some kind of entry point, so end user doesn't even notice we do not work. strictly with iOS. We have an entry point and we work starting from there. And I think we need some kind of environment for providing APIs, platform APIs to user. Let's say if we want to call to accelerometer, if we want to send SMS, we know that all major vendors, they provide the API to do that. But, if we look at iOS or Android, we have lots of capabilities. Can we do that? Are we able somehow get these functions? What can help us with this problem?
So I suppose if we step back one slide, we're saying at the bottom here, your application library, we're going to turn into an ELF file, and we're providing on different systems, our platform-dependent implementations for functions is at the top. We're saying that part is responsible for providing, yes, accelerometer values, opening of files, and it provides all those services down to your application, which is coming from your file.
Okay. Next, to the next slide. Again, say that also we have the special environment for providing all these kind of things.
So yes, we're saying this system whereby you have a entirely platform independent code loaded from an ELF file is one of the key features of the SDK that we work on. And the advantage that this has is that you've compiled your application once and you've created your ELF binary, and then we provide, that's what the SDK we work on provides, is the loader level, the system services for different platforms.
In fact, what we provide is a different platform. You do not program, you do not develop your game for iOS or for Android specifically. You do develop your game for Belyy SDK, for Belyy platform. And in fact, it is not an engine, it is not a framework, it is the platform. We definitely know that almost every mobile platform provides an access to native code, allows you to run the native code, maybe except Windows Phone 7. There are lots of efforts to make Microsoft allow that. We hope Windows Phone 8 will definitely allow it. So we can create loaders for all the platforms, including iOS, Android, Bada, Symbian, whatever, smart TVs, desktop can be not the exception from that rule. It is a Hewlett-Packard WebOS that is currently not in development any longer. It is QNX, the operational system for Reading Playbook. Other platforms like old Windows Mobile 5.0, 6.0. And what else? Our embedded execution environment provides an access to all those cool features like location services, threads, SMS, sound recording. And we definitely can say that if anything is not included into that list, our developers have the possibility to write it by themselves. Do not wait for a big company to do that. Yeah. That's what we do, that's what we work at, and we would be happy to answer your questions. They can be more or less specific, technical. You can ask about weather, about, I don't know, atmosphere in our team, anything. Thank you for your attention. That's what we wanted to tell you. We expose you our secret technology, magic. Yeah, you can create your own startup and do better platform. Thank you very much.
Thanks.
Do you have any questions? Yeah.
It would be great if we hear some specifics about your implementation. And I suppose it's.
What task did you make with this library?
Sorry.
What task have you done with this library already?
You mean what products
Yeah.
can be
Yeah.
seen? Okay.
Did you have some products?
Yeah. Have you heard about Call of Duty game?
Sure.
Yeah.
And you ever played Call of Duty game on iOS, iPad, iPod, iPhone, and those top selling apps?
Yeah, so the Marmalade SDK is primarily focused at games and
Yeah, we can say the
Cross.
vast majority of our products are games, and it is widely used by such big companies like Electronic Arts, Konami, Square Enix, Bandai Namco, PopCap. You know that Kadrou, Zeptolabs, PopCap moved their Plants vs Zombies to Marmalade to get cross-platform. Yeah, so Need for Speed, Kadrou.
Okay. Why do you prefer dynamic linking, not the static linking?
that's because
Why do you need all the things with some loader in different platforms? Why you can just use the static linking and that's all? You have for each platform you will have the executable, and that's the better way, I think.
the idea is that the developer can produce one package which contains that application library and all their resources, and they're able to deploy that to different platforms without ever even running their linker again, without having to, they can give even that package to a different company and it can be deployed to a new platform without any modification to the original binary or assets at all.
One question. You wrote that you replaced 17 system calls to support, right? And if some games is written for Windows, and guys just want to port it to the, like, let's say Linux, they can do this with your SDK, right? They should write it in Linux first, maybe for iOS, and then it became portable for all the different operating systems.
Actually, no. They work with their user application code base and nothing else. In fact, they do not see that magic. You can open the same project both in Windows, iOS, or Linux. You see your code and you use compilers to compile your application code. You do not even think about the loader. It's what we do. We just provide you working loader. We just provide you working environment.
So you can replace Windows AP2. Like if you have create file Windows API, we can replace it with your function and just compile it?
Yes, you have the choice of either Marmalade actually provides a set of APIs for all these functions, or you can use like the C standard library functions. So the Marmalade API is sort of
Oh,
okay,
covers
so
a
we
broader
can use
range of
both.
things. They
Yes,
cover
in
like-
fact, you can write your application code using direct OpenGL calls, and it will work on all the platforms because we do intercept your calls to OpenGL. Maybe we add profiling. Let's say we count how many times you call GL draw race. We do measure the performance for you. We do add tracing for you. All that stuff. And you just write a pure C or C++ code. We do confirm POSIX, and
So POSIX plus OpenGL
yes, POSIX plus.
plus sort of our own APIs for things which are not covered by those things, such as accelerometer or
So
SMS
you can
services.
take any open source C++ or C library, just compile it and run it. You don't even need to change anything. Minor changes to make it work.
What if I use like DirectX? I should move to the OpenGL.
Originally, we were targeting mobile platforms, and DirectX is not present on mobile platforms. OpenGL only.
So in this situation, I have to move the code to the OpenGL and then
Yeah,
run it.
yeah. If your let's say drawing code is separated well from the business logic, I don't think it would
Yeah.
take a big effort
understand.
to.
Yeah, I mean, OpenGL is a sort of platform-independent option for mobile platforms. We do also provide a sort of render extraction layer which is able to target either OpenGL or software rendering on very old devices, or we're sort of investigating adding support for DirectX for newer platforms.
Desktop platforms.
Yes.
Do you base your library on the Boost, or you have your own bunch of code for different platforms?
We don't use Boost internally, but
We
So
don't-
you
we
have
don't-
your own
we don't use it.
implementation for the threads, for some file system operation, and
We don't use it for our loader, but you are free to use it inside your application.
I understand it's about the stability of your library. If you're based on the Boost, and the Boost existed a long time ago, for a long time, it's one thing. And if it's new library, that's another thing.
well, I guess our library's also been around for quite a long time.
How long?
It's about 7 or 8 years, which I don't know how old Boost is, but it's probably similar vintage. I mean, the system was originally invented for the Brew platform, which I don't know if anybody's any experience of. Was a pretty, well, at times unreliable platform, so something that we also try to offer the developer is we've sort of fixed those or worked around those platform bugs for you.
I hope.
Yes. That's the guarantee that we're sort of offering to the developer.
Thank you. I have no question. Okay.
What about
No?
native graphical user interface on each of the platforms? Do you replace them with some of your implementation, or
That's functionality that we've actually recently looked at adding, well, has been added to the SDK, is a common interface for accessing the platform's UI elements. So you are now able to, in Marmalade, create native buttons on
Text fields or whatever. Or if we talk about input sources for all those mobiles, we do use it for a long time. So you see the native keyboard with let's say if we talk about Android swipe input, you know, you can definitely use it with Marmalade. You can enter text with swipe input to a common text field. Yes.
What happens if some application needs to use, let's say, accelerometer, and should it like make a workaround about if the device doesn't support this feature, or your platform knows how to deal with it somehow?
The theory is that your application queries, like, is there an accelerometer available on the device, and then switches its behavior depending on if that feature is available.
Your application just ask.
Okay.
Just ask, and that's all.
But instead of creating like two separate builds, one for accelerometer enabled, one without accelerometer support, you do that dynamically by querying if it's available.
What's the license of your library?
As
License. You mean
Commercial?
license model?
Yeah.
That's not a sort of C++ question. We can sort it out.
well, it's free. You're free to evaluate it.
Yes.
You can get a demo version for a limited time. At the moment, it's under commercial license, so it's
Yes.
$99
For basic.
for a basic license.
149.
Oh, they put up the price.
Yeah.
Who will pay more?
There are people who know more about our commercial model than we do.
Okay. Any question?
Maybe you have any other question. You are free to ask the biggest secrets of the technology, guys.
We might not know the answers, but
Yes.
We understand.
Is there any integrated environment for Marmalade? Can I use my Eclipse, Visual Studio? Can I make a development with Marmalade on macOS X?
that's a good question. Yes, Marmalade SDK is available for Windows and Mac. On Windows, you can use all the different versions of Visual Studio or Qt Creator. On Mac, you can use Xcode or build on the command line using scones. But you can use your favourite IDE along with Marmalade. You just need a Marmalade project separately.
So, thank you very much for listening to us.
Thank you.
Thank you.